We will conclude section 8.1 here, looking at experimental probability as opposed to theoretical. They actually go together nicely. You actually can test out theoretical probability by doing many trials of said event. Let's say the event is flipping a coin. If you were to flip a coin, say 10 times, you would expect to get a tails half the time. So you'd expect to get 5 out of 10. Doesn't mean you would, but the process of you flipping that coin 10 times and then recording the results actually gives you the experimental probability because you're experimenting with that trial of flipping the coin. So that's how experimental is different in its terms of its probability versus, let's say, theoretical. So if we look at example number 2, they ask us to take like a recording of the number of cars that pull into the parking lot in terms of their color. When we go through that process of actually looking at that, you'll notice that we're going to be taking that experimental data and then trying to come up with or make a prediction from that data. That is the use of experimental data to create probabilities. So let's just point one thing out before we go. Let's get the definition here of experimental probability. You can see it here on the screen. That's the probability of an event, and it's based on the outcomes of a series of trials. So like the coin flipping example, if you flip the coin 10 times, 100 times, 300 times, and then record those results, that is that process of experimental probabilities. You're creating those trials, and then from those trials, you would make a call and say, hey, I think it's 50% chance or very near 50% chance of getting tails. So as the number of trials, this is very important too, as the number of trials increases, the probability of an event will get closer to the actual or theoretical probability of that event occurring. So let's look at example 2 here. I've got this for us. Let's apply some of that to this situation. It's telling us that, we're not going to be able to do that work on this screen. My pencil disappeared. So we'll just read it and then we'll go back and do the work on the other screen. So it says this: the colors of a car passing in the school gate one morning are given in this table. So we got these frequencies of cars' colors happening. It wants us to estimate the probability that the next car to pass the school gates will be red. So they've recorded 110 cars here. Out of those 110 cars, there's been 26 red cars pull into the parking lot. So you would use that frequency out of the total to record the the experimental probability. So to answer this first one, we would have to use the data that we have at hand. We would say that it would be about 26 out of 110. So if we go calculate that 26, there were 26 red cars that showed up out of 110 recorded. Well, then we could get an approximation of that by doing that calculation. So if you take 26 and you divide it by 110, we get about 24% chance. So there's a 0.236 or about 24% chance. So a little bit less than 1 in 4 chance of the next car that comes into the parking lot to be red. So that's the use of experimental probability and experimental data to make predictions. It's useful. It doesn't mean it's perfect, but it is useful. So if we go back and look at the other part here, it says now, using this information, if 150 cars were to pass through the school gate the next day, they wanted to estimate, well, what number of cars would you expect to be red that morning? So now this is using that expected value idea from the last part of that we went through with section 8.1 here with theoretical. So expected value now will be based upon that previous, what was it, 24%. So now we would take the number of trials that we would do there out of the 150 cars. We would actually do that math this way. We would take, okay, what are the chances out of this 150 that they're going to be red? So we would multiply that by this 0.24 or 0.236 if you wanted to get an approximation. So if we go times 150, the expected number of cars would be about 36. They actually have it 35.4. We know we don't have parts of cars, so we would, let's just say that's going to be about, we'll round it down there to 30, about 35 red cars. All right. So the last part here, part C, it's a good example. Part C then is extending this a little bit, and it's asking, well, what's an improved estimate of the probability of the next car to pass this school gate being red? So now they've done 2 days back to back, and so now we can say, well, hey, we got 20 more cars out of 92. We can combine those 2 days together for reds to see what would be an improved experimental data, because now we have more trials. It should be a better predictor now because there's more of them, of what's going on here. So we had 92 and 20 of them are red. So now in our new set of information, this is like day 2. So here's day 1, day 2. Now we have 20. What was that out of 92 of them? Let's double check that. So 20 out of 92 were red this time. And so we had that 20 out of 92, but then we would also add to that the 26 out of 110. Now understand this is a ratio. We're not adding two fractions together. We're combining the amount of reds out of the total number of trials. So don't think that I'm adding these two together. I'm adding tops and bottoms. And so this would be what? 46 out of, what is that? 212? I think if I did my math right there. Okay. Oh, sorry, 202. I did not do math right there. Yeah, 202. All right, let's get this fixed up here. Bad teacher. 202. Okay. What's wrong with my brain right now? Yeah, that works. All right, so now if we took that percentage, we would go what? 46 divided by 202, and that gets us at about 23%. So it's actually 22.77. You know, it's holding pretty steady right there, right around that 24, 23% mark. We're going to call this now an improved. This is our improved estimate. What are the chances that, you know, the next car, the 203rd car being red? I'm saying 203 because we've got 202 trials at this point. The next car to come in to be red, we would use this estimate here. So it would be about, what is that? 22.8% versus that 23.6%. Okay. Now, if we kept doing this and we kept recording data, if we did this for a week or a month, we would get even more and more data to support our claim. There is experimental probability. All of section 8.1 and its homework should be encapsulated in and dealt with in these set of notes that we've gone through and examples. We'll see you guys in the next video. Make sure you ask questions when you don't understand something. All right, talk to you soon.